Okay, so now we're going to continue on with radian measures, and we're going to go through some common angles, and we're going to relate this to the circumference of a circle. Okay, so we know that the circumference of a circle is given by the formula of 2 pi r, right? So 2 pi radians, or excuse me, 2 pi times the radius of a circle. So we know the circumference C is equal to 2 pi r. Okay. Obviously, we also can use pi times the diameter, but again, we're using the radius in this case for a specific reason. Okay. So now, so we know that we can calculate 2 pi using our calculator. We know that's going to be approximately 6.28. So 6 radians and a little over a quarter, right? So again, my artistic talent notwithstanding, so this is a circle here. And so notice that if I start here on the x-axis at 0, I can go 1 radian, right? So 1 radian here would be here. And then I can go another radian, so that's 2. And then I can go another radian, that's 3, right? And then we can go another radian, that's 4. Another radian, 5, another radian, 6, and then we got a little bit here, a little over a quarter of the circle for the last bit to bring us all the way full circle, right? So remember, the circumference is the distance around the circle. So in this case, the circumference, we're representing the circumference in radian by mapping it out, and we see that it's a little over 6 radians wide. So we know 2 pi. Again, if we look at pi, right, pi is approximately 3.14159, so it's a little more than 3 radians, right? So here we have 1, 2, 3, and a little sliver. Okay, so again, just for a visual, that's what we mean. So again, so we can relate it to the idea of a circumference of a circle, and the arc length, where was I going? So Connor, again, so arc length, right? So that's the circumference, but arc length can be also corresponded to the same formula, right? So we can look at S equal to 2 pi r right, where S is just represents the arc length, but it's one full revolution, right? So we're just replacing C for circumference with S. So now, what else do I want to say about this? Now, the units of S and R are the same, right? So you can see that from the formula. So because it's length, so they're going to have the same unit of measurements. But if we take the ratio of S and R, right, as we saw before, right, so again, theta in radians is represented by S over R, okay, but that doesn't have any units. It is a real number, okay. So how do we get the measurement of the full circle? Well, let's demonstrate this. So if we take S over R, right, equals theta. So here's S. So we're going to divide both sides by R. And what do we get? We get theta is equal to 2 pi. Look at that. 2 pi radians. So one full revolution, the angle is going to be 2 pi radians. Okay. Now, What about some other ones? Well, what about if I do a, let's do a half revolution, right? What about this one? Let's do a half revolution. What do we get? Well, again, we get a half revolution is going to be 1/2 of 2 pi, right? Because we know a full revolution is 2 pi. What's a half revolution? Well, it's going to be half of that, so that's going to be pi. And then, of course, if we do a fourth revolution, right? So 1/4 of the total. So 1/4 of 2 pi is going to be pi over 2, right? If we go to a third of a revolution, right? 1/3 of a revolution, or excuse me, not third, 1/2. Yeah, 1/3. So 1/3 of a revolution or excuse me, yeah, 1/3. Or it's not 1/3. Oh no, this would be 1/6. So 1/6 of a revolution. Think about this. So 1/6 of a revolution, we're going to take 1/6 of pi, or 2 pi, right? So again, we're just going to take 2 pi divided by 6, right? So we want 1/6 of a revolution. We know that 1 full revolution is 2 pi. We'll take 1/6 of that, and we get 1/3 pi. Pi over 3. And then here, what is this? This represents what? 1, 2, 3, 4. So they're 1/8 of a revolution. So again, if we take 2 pi divided by 8, this is going to become pi over 4. So that's pi over 4. So this angle here is pi over 4. This angle here is pi over 3. What about this angle here? Well, this represents, 1, 2, 3, 4, 5, 6, right? So that's 1/2. So it's going to be 1/12 of a revolution, right? So we're going to take 1 revolution, which is 2 pi, divided by 12, and we get pi over 6. So these are the common angles that we run into a lot when we're dealing with radians. Okay? And so make sure you know these, right? So, and then because these are going to correspond to some very common angles and degrees too. I'm not going to get into that, but you could figure it out on your own because we know how many degrees are in a full revolution, so you can find the equivalents, but we'll talk about that later. But these are the common angles and radians that we can find based on our discussion here on circumference. All right, cool. Let's see here. Is there anything else I want to say? No, we'll talk about that next time. Okay, have a great day.